Hi, Assalamualaikum. I am Nushrada binti Nordin, and my matric number is 189873, and I am from Group 5, and this is my group member, Tan Wei En, at Ummi Fatihah binti Muhammad Lofi, and we are assigned to do the assignment 2 from chapter 4 for the question number 5. So basically, this is the questions is about the carbon steel ball that we have to find how long the analysis process will take, and then we have to determine the total rate of heat transfer from the balls to the ambient air if the ball is 2500 K. So this is our assumption. We assume that the ball are spherical in shape with radius 4 mm. The thermal properties of the balls are constant. The heat transfer coefficient is constant and uniform over the entire surface. The Biot number is less than 0.1, so that the Lambert system analysis is applicable. Okay, we will verify this later in our calculation. So the properties of the thermal conductivity, density, and specific heat of the balls are given to be like this: Km 54 for the K, and for the density is 7833, and for the Cp is 0.465 kilojoule per kilogram degree Celsius. So the analysis is the characteristic lengths of the balls and the Biot number are. So basically, this is our first step. We have to find the Biot number to verify whether it is Lambert system, which is less than 0.1. So we find the LC and then use this formula V over A, area of the surface, volume over area of the surface, and then we get 1.33 multiplied with 10 to the power of -3 meter. Then we calculate the Biot number using this formula, H times 2LC over K, and then we get 1.847 times 10 to the power of -3. So the Biot number is less than 0.1. So sorry, actually there is typo over there. Then the second step, we find the value of the exponent b using this formula that we can get from the books, and then we get the final answer is 0.0015 second to the power of -1. Then we find the time that we need for the annealing process using this formula, and then we insert the value here and here. Then we get the time is 167.2 seconds, which means equal to 2.75 minutes. Okay, we've finished for the first part. Next, we find the heat transfer, Q. Firstly, we have to find the mass. So using this formula, we get the mass is 2.01 times 10 to the power of -3 kilogram. Then we can use this M to insert in the heat transfer formula, Q equal to mc delta T. Then we insert this formula, the value in this formula, and then we get negative 0.781 kilojoule. And lastly, the question want us to find the total rate of transfer for the ball. So this is our formula that we use. We find the Q dot equal to the N dot of the ball time to the Q. So this is the value that we get, which is 2500 per hour times to negative 0.781 kilojoule, and then we get this heat transfer, negative 1952.5 kilojoule per hour, which is equal to 542 watts. Okay, for your informations, the negative sign here is mean that the heat leave from leaving the ball from 900 degrees Celsius to 100 degrees Celsius. So that's all from us. Thank you.
Okay, this is the second part of the question. Using Excel software, investigate the effect of the initial temperature of the balls on the annealing time and the total rate of heat transfer. The temperature vary from 500 Celsius to 1000 Celsius. So we have to plot time and the total rate of heat transfer as a function of the initial temperature, and the result will be discussed.
So we change our temperature 1 from the 500 until 1000. So we use this formula Q equals to mCp delta T. So when the T initial is 500, and then we get this value and this value, and then for the 600 we get this value. Until 1000 we use the same formula from here. Okay, basically this calculation are same like previous calculation that we have made. Okay, so for the last part, we are required to plot the time and the total rate of heat transfer as a function of the initial temperature. So at first, we have to come out with T by using this formula that when time is equals to 0, our T initial will be 900, and the Q that we get is negative 0.7812, and so for Q dot. Okay, so when the temperature and so when the time increases, the temperature slowly cools down of the copper ball, and then the Q value we get also varies from time to time. So after getting all of the values, we'll plot it into a graph which look like this. When T is 0 or approaching to the time increasing, the heat transfer is slowly decreasing until the time is until it's reached 167.206 seconds, which is the T2 that we want, 100 degrees Celsius. That's all from us. Thank you.
Thank you.